Hello, everybody. How's it going so far? Second day. Second talk? Third talk? Let me tell you about my journey on the web. So I'm now 34 years old, and I was one of these lucky people that had a tech-savvy father. So I had internet when internet wasn't a thing, when Google wasn't there yet. So and then what I did is I was entering URLs into this thing that was now a browser, and I was not really sure what I should do there. So this was all pre-Google. So I was like, yeah, I cannot dial in, and that's it. But I was not really convinced that this is a thing. So when I'm born in Germany, and maybe when you're from Germany too, then this happened. GOTO.com. Has anyone used this? Oh, come on. This was one of the first social networks that I used. It was pre-Facebook, pre-Google. And there it was 1999. I'm from there. There's not much there. But I found myself talking to people from Berlin. And we were talking mainly about music, because the people from my hometown were not sharing my music interests. And this was for the first time when I figured out that, oh wow, the web connects people. So I moved to Berlin, and I became a sound engineer, because this is what you do when you like music and you do music. And you get unhappy because that's maybe not the job was not for me. And then 2010, something crucial in my life happened. I changed jobs, and I became a web developer. More or less by accident, because I always thought, well, I was always good with computers, so let's give this a try. And then the whole statement that the web connects people from one day to the other changed to we connect people, because I was not building for the web. We enable people. Depending on what we build, we can help people out, and we can bring people to succeed, and we help people. And let me just quickly introduce myself. I'm Stefan. I work for a company called Twilio. Twilio is a communications API, so in case you wonder how to send SMS, make phone calls with real phone numbers, build bots, send emails, do 2FA, you can check that out. But that's not why I'm here. I'm here because, hey, I'm Stefan, and I want to be a responsible developer. So when we look at the world is fairly big. There was 1999, middle of nowhere. When we now switch forward 20 years, the whole topic of the internet changed a little bit. I'm not the biggest fan of internet stats, right? But let's have a quick look. Where are the most internet users coming from today? Anyone? It's China, it's India, and it's the United States. Why should I care, right? But I also write on my blog very often, let's say, and only looking at my analytics, last month I had 300 people from Brazil reading my articles, 100 people from Vietnam, 100 people from South Africa. I don't know about you, but I'm very excited about this. But at the end, it really doesn't matter, because we should be building for everybody. And when I started doing web development 10 years ago, we had this sentence: we don't have users in a certain region of the world. We don't have users that use a mobile device to browse the internet, right? Guess what? When you say this kind of statement, you're basically creating a chicken and egg problem. When you're not building stuff for users, these users won't use your stuff. And building for the web today, or building a good website, is actually very hard. You have to consider design. Did you know that in certain areas of Asia, red and green, and the meaning of it is inverted? So red is something good, and green is something bad? Good luck with that when you ship globally. You have to consider good content. You have to take care of performance. You have to make it accessible, because, yeah, there are people out there that use assistive technology to browse the web. I'm a hipster JavaScript developer, right? And you have to figure out what to use. I can bike shed for days before actually writing my first line of code. You have to optimize the network stack, and you have to make it work on computers, phones, fridges, cars, whatever we have. And in the next 40 minutes, I want to talk about the network stack. So let's talk about HTTP. When the browser makes a request to a resource, what happens is that it will send a set of key value pairs, so-called request headers. And the server then will respond with a set of key-value pairs, the response headers, and the actual resource. So we're dealing with requests and response headers. And just because it was trending 3 or 4 months ago to buy a .dev domain, so what I did is I bought a .dev domain. So what you see here is the responsible.dev. It's a fairly simple site. But you see already that JavaScript is disabled right now. So let's enable JavaScript. Hoppala. So what you see there is a permission dialog that I don't want. There are unicorns showing up, and I'm using CodePen, which is an online code editor, to frame the site. And now someone can just pretend to be my responsible dev site. But it is not this actual site. So I asked myself the question, how can we use only headers to make this site better? Which brings me to the first topic, that the web is a very, very scary place. Just a few months ago, hundreds of sites were mining cryptocurrency, and nobody noticed. Think of this. Your mother mines cryptocurrency in her phone without knowing. And all the site owners didn't know. Because what happened? A third-party script was hacked. But nobody noticed. This is one of my favorite ones. It's fairly old. It's 5 years old. But this is a podcast episode of Shop Talk. And they had a hacker on the show. And the hacker social engineered his way into a CDN just by calling and being nice, right? This is how social engineering works. And he had access to the CDN that was hosting the global jQuery. Think of this. You can break the internet with that. He didn't, but just a few months ago, this happened too. So the event stream package is a very popular package in the Node ecosystem. It's unmaintained though. And if you do open source and someone comes to you and says, hey, Stefan, do you need help? You are like, yes. So the person that got access rights then just pushed several releases and at some point put more malicious code in there. This was on millions of machines over the world. Or my colleague, Kelly, she just called a lot of call centers, and guess what? She got so much personal information just by pretending to be someone. Because people want to serve, and when you're nice, usually people give you access. So what I want to tell you is that we always rely on others, and this is why the web has to be safe. And the foundation for a safe internet is HTTPS. HTTPS in the first place makes it possible, or makes it not possible, that people that know how to do it can sniff your HTTP traffic. People that deal with these kind of things, they will spawn a public Wi-Fi, you connect to it, and they will just sniff what goes in and out. Takes them 5 minutes. Over HTTPS, that's not possible anymore. Also, browser vendors are pushing for HTTPS, so cutting-edge features are only working over secure connections, which is a good thing. So, and since certificates are free, which is now for a few years like this, I always thought that, well, we're all green with a green lock now, right? Then you find sites like this, that is called Why No HTTPS. It's not 100% accurate anymore, but if you're German, guess what? The ARD ships HTTP only. We have 2019. So I think that HTTPS is the first counterpart there. And when you then enable HTTPS, what you have to do is, you have to ensure encryption. So how do you do this? What you can do is you can send a response header that is called strict transport security, and you can then define in seconds to the browser, hey, this connection should only be working over HTTPS for the next 1,000 seconds. You can define the directive that it should include subdomains. And if you feel really fancy, you can define a preload directive. So the preload directive enables you to do one thing. You can go to this fancy-looking site, submit the URL, and eventually your website or your URL will end up in this file. This is a JSON file embedded in the Chromium source. And it's just a big whitelisting of all the sites that should only work over HTTPS. This file is propagated across browser vendors. And in case you ever wondered why you cannot use .dev for your local environment over HTTP anymore, this file is the reason. HTTPS or HSTS is not only good for security though. Guess what happens? I'm sitting in the Deutsche Bahn and I'm typing something in my URL bar. The browser will make this request. This is an unsecured request, which takes 2, 3, 4, 5 seconds just to tell me, nope, we do HTTPS here. With HSTS and this setting, you can prevent this first hop, which is a good thing. So what's the support for HSTS today? We're pretty green, which makes me fairly happy. So now let's say that you're building with a massive production website and you switch on HTTPS. Then you're running into mixed content warnings because the browser will tell you, well, you're on a secure connection and you're trying to access something that is not secure. How do you upgrade all the HTTP requests then? Well, there's another header that is called Content Security Policy, and you can magically upgrade all the requests that are not going into a secure connection with this. This is not the main purpose of CSP, though, Content Security Policy. CSP there is to limit what is actually allowed in your websites. And when you have a look at websites today, there's a lot of stuff going on. So when you, for example, use a tool like requestmap.webperf.tools, this will analyze how many domains and URLs will be loaded in your page. This is not for Spiegel, right? This is a German news site, so there is a lot of tracking going on. But this is a lot of third-party code running in your site. And with CSP, you can configure basically almost everything. Where should style sheets come from? Where should JavaScript come from? Which images should be allowed to load? And then there's fancy stuff like from where can we prefetch stuff? So if you want to enable this, you can use this as a meta element in the head of your document. Or if you're like a fancy header person, you ship a header like this, which I ship from a private website. So on shipping CSP is not the most easy thing in the world. Usually you ship CSP, and you forgot something, everything is broken, you roll it back, you edit, you deploy again, everything is broken, and you do this 3 times. So what you want to do is you want to start with a report-only header. So this header allows you to define an endpoint, which will then accept requests from the browser. So the browser will basically do, hey, Stefan, I would block this if this would be active. And then you just wait and you go over the logs, and at some point you make it active. If you know CSP, and you look at this carefully, you're probably already saying, Stefan, this is not a safe CSP header. Because I have this in there. This allows inline JavaScript execution. And the reason for this is that I'm using a cutting-edge JavaScript framework, and they don't give me a way yet to work around this. So when you work with inline JavaScript, there are 2 ways to deal with this. So you can define a hashed value, which then whitelists this inline script. So this is pretty cool. This has the downside, though, that when you change your script and you're going with the headers, you have to change the header configuration. What you can do, too, is you can use a nonce property, which basically acts as an ID, and with this you can whitelist certain inline scripts. This is more handy for this use case. So how's the support for CSP today? CSP exists in 2 levels. So level 1, pretty green. Level 2, we're getting there. But I asked myself the question, okay, how many sites are actually using CSP today? Because this is a big safety net for you when jQuery gets hacked and starts mining bitcoins. So I had a look at HTTP Archive. HTTP Archive is a site or a project that crawls all the biggest sites in the world. And you can then write queries against the data that they create. So how many pages use CSP today? Any guesses? 10%. 20%. We're at 6% using CSP. And I honestly think that we can do better, because this is just safety for our users. So when you want to do CSP, the goal is, or the rule is, deploy report only, monitor, and then make it active. And then we have another big topic that I only want to briefly touch, which is the set cookie header. And I think it may be a good idea to disallow third-party cookies. So what happens when you send a response header that is set cookie? So user makes a request to a server, you set a cookie, that is cool. So when the user then opens or goes to the site again, it will send the cookie, and that's it. So now the person navigates away to a different website, and this website maybe makes a request. It can be an image, can be a post, could be a GET, to your server again. Well, it sends the cookies. And this can be a big security or privacy issue. This is why we have CSRF tokens in our controllers. So what you can do instead is you can use the same site attribute for cookies. So this is available in 3 options. So Lux will only allow top-level navigation cookie send, and Strict basically will only send cookies when the URL shows the same as the request. What's the support for same-site cookies today? Well, we're pretty much there, so you can use that today. If you want to learn more about same-site cookies, you can go to this page from the Google folks, and they explain it quite nicely. So, with these headers, when I go to the responsible.dev/safe, you see that the unicorns are gone, because the third-party script is blocked, because I didn't allow it. And when I go to CodePen, I also disallowed that my page can be framed with CSP, which makes this little site a little bit safer. So you see a blank screen because it was disallowed via CSP. So these few headers make this page a little bit safer because the web is crucial for people. And I hang out on Twitter quite a little bit, and more I read these statements. Your stuff doesn't work in Africa. Why should I care, right? The thing, though, this is not about Africa. I also travel quite a little bit. And this happens when I go to the Ukraine to speak at a conference. I get out of the plane, get the SMS for my data usage in this country. It looks like this, still too tiny, and this is ridiculous. So O2 is telling me you get 6 megabytes for €2, but you have to use it in 24 hours. The average website today is 2.5 meg. This holds 30 seconds for €2. So I think data consumption is important. So and if you want to learn more about what people pay on certain circumstances, you can go, for example, to whatdoesmysitecost.com. This is a project by Tim Cudlek, and he pairs data consumption with the income in a certain country. Because when you think of this, people pay different amount of money depending on where they're coming from. Right? With this data, you can see, yeah, this is now, I don't know, 1% of the monthly income of the person from this country. This is super freaking cool data. And looking at something like this is important because I believe that the web has to be affordable. Because, well, the internet is everywhere. And a big part of this is that we don't want to request the same content over and over and over again. And there are only 2 big problems in computer science, right? Naming and caching. So I will only briefly touch on this. So what you want to do is you want to set a cache control header on your resources. What you can define in seconds there, how long this resource should be used from the cache. The problem with this header is, though, that this doesn't necessarily mean that the browser doesn't make a request. Under certain circumstances, the browser will revalidate if the resource is still the right one. But does the browser has to revalidate when I ship styles.somehash.css? No, I don't think so, because if the file changed, well, then it's a different file. So what you can do is you can ship the immutable directive, which tells the browser, hey, this goes into your cache, no matter what, no revalidation. Facebook shipped this with great success, and they saved so many requests, because what do people do on Facebook? Refresh, 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 revalidate, revalidate, revalidate. With this, they saved a lot of requests. For certain browsers, but we're slowly getting there. So because caching is a tough topic by itself, if you want to dig deeper, because there are 15 directives with not very intuitive names, you can have a look at this article by Harry Roberts, Cache Control for Civilians. This is an excellent resource. So with this, we can now save requests, which is a good thing, but I think we should send the right data in the first place. Right? Maybe? And guess what? When you type a URL in the browser, what the browser will send to the server is this, accept encoding. This is a request header. And you see common or common compression algorithm in there, but you also see BR in there, which stands for Brotli, which is a different compression algorithm. So I grabbed the style sheet, 100K, I compressed it with gzip and Brotli, which led to 15K under gzip and 10K Brotli. And I now may get the response, Stefan, 5K. Come on, who cares about 5K? Depending on where you work, this is a big deal. So the JavaScript engineers at Wikipedia worked for months to shape 9K off, which resulted in 1.4 terabytes of saved data. I think this is very cool. I mean, think of this, you shape 5K. Well, anyways, and this is why maybe, depending on your scale, these 5 or 10K make a difference. If you have played around with Brotli, you might say another thing to me, which is like, yeah, Stefan, this is all cool, but Brotli compression is so slow, which is basically comparing apples with oranges. So when you look at gzip and Brotli, gzip works with 9 modes. Brotli works with 11 modes. They both have a default mode. The gzip default mode was chosen to be 6. This is the sweet spot for file savings and quick encoding. The Brotli default mode is 11, which was purely chosen to give the smallest file. When you tweak the Brotli settings now to run in a different mode, in level 4, for example, Brotli tends to compress better than gzip. This is why you can go, for example, to go to Cloudflare and just hit a button and say, I want to use Brotli. They do it on the fly. It's as fast as gzip, but compresses better. But front-end developers are shipping a build process anyways, right? So maybe we can just, we do Webpack and minifications and all that stuff. Why don't we put compression in there too and just ship it statically? If you want to learn more about Brotli compression, the friends of Akamai did an extensive research. That's also a little bit older, but it's still very valid. So you can have a look at this. So how's the support for Brotli compression today? We're there. And when you look around at all the big players, they're shipping Brotli. But unfortunately, I only see this at the very, very big players, because maybe the 5K matters for them, and they don't for us. So we're shipping the right compression, but then there's still the big problem with the stuff that is the most data on the web, which is media. And I, as a front-end developer, I'm guilty of writing something like this. So what you see there is a picture element that does a feature detection check for WebP, which is an image format that is a little bit smaller than JPEG usually, and it does responsive images to ship the right image for the right viewport dimension. Guess what? When the browser makes a request for an image, it also sends this request header, which tells you what image formats are supported. So when we talk about WebP, what is the support for WebP today? Safari is not there yet, but I feel like the peer pressure is pretty high now, so I feel like it will come. And you can now pair this header that tells you about image formats with this header, which is accept ch. This stands for client hints. And this is the response header from the server. And what I'm doing there is like, hey, browser, please tell me about the width of the images and the viewport width for the next 100 seconds. What happens now is that when the browser requests the image, it tells us this without, or with just a little bit of additional markup. So what you have to do is you have to give in the HTML a sizes attribute, because the browser needs to know how the image is laid out. And then you come up with something like this. And this is all the information you need for responsive images. You know what is supported. You know what the image width is. This works for high-resolution images and retina displays too. And then you can adjust your server or your service worker to just ship the right images, which I think is very cool. This is very cutting edge, though, and if you want to learn more about this, Jeremy Wagner talks a lot about this. Take a client hint, so before you jump all in on this, you should do a little bit more research there. And speaking about all the people that are accessing the internet around the world, there are a lot of people that want just to save data. And it turns out there's also a save data header, right? That's a request header. You can turn that on in your browser of choice, and then you can access this also in JavaScript if you want to. And I think this is a very, very good idea, right? Because when I'm in the Ukraine, I want to save data. So there are applications out there that have a save data mode. So this is in German now. So this is Twitter, the progressive web app. They have a save data mode, which is cool. Then they load low-res images, and you have to opt in if you want to load images, which is a great approach. But the Twitter web app is not reacting to the save data header. They're just ignoring that. They build their own stuff. And to enable save data in the first place, what you have to do is, for Chrome desktop, you have to install a Chrome extension to send this header. It's buried 3 levels deep in the Firefox settings. And now I'm just slowly going a little bit into rant mode, because I think that's just the wrong approach for the web. Why don't browsers look like this? It shouldn't be buried somewhere. We should always provide an easy way to save data. And while we're at that, right, I'm a hipster JavaScript front-end developer, right? And we do this now for a year. Prefer a dark interface. The only people that see dark interfaces right now are developers, because no normal person knows how to enable this setting. Prefer reduced motion is the same thing. This is an accessibility setting. This is 2 levels deep inside of my operating system. Nobody uses this because browsers don't look like this. All these settings are so powerful, but I think we're completely missing the point right now, because they're not accessible for normal people. Speaking about the save data mode, though, if you want to work with save data, be careful, because Google does what Google does. When you send when you accept save data headers, it could be that Google Chrome will proxy your stuff, because Google thinks that they know better how to make a fast website than you do. And maybe they're right. But I'm not sure if I like Google being in the middle of this, so you have to be careful with this. And I'm definitely not sure if I like that. If you want to tell Google to not transfer your requests under save data conditions, you have to set a no transfer cache directive. And if you're using CDNs and proxy servers, you have to define a vary header to tell, hey, the results can vary depending on this header too. So then, unfortunately, I always thought you don't see save data very often in the wild. And then something like this happens. Shopify, right, a big player, they work with a save data header. And when you look at this, in India and Brazil, 20% of the requests have this header enabled. Think of this. This is very hard to turn on. A person really had to Google, how can I save data in this browser? Went down 3 levels, and every 5th person sends this header. I think we should building stuff that reacts to this. If you're curious on how to work with this article was pretty decent if you want to start working with save data. And if you're still skeptical, shipping a solution that is not consuming so much data doesn't necessarily mean that the experience will suffer. Maybe you can drop the carousel that nobody cares about. Maybe you can ship low-res images. Maybe don't load fonts that this person really don't want to see. These 20% of people have save data on for a reason, and I think we should value this. So when we go to the responsible.dev/affordable, you will see that first of all I'm shipping Brotli, which saves a few bytes on the wire. And you see the header JPEG there. But I'm shipping a WebP because I have the information that this browser supports WebP. And also when I resize the browser window, you see that the image gets smaller that is responded. Because I have all the information thanks to client hints. So when we look at the headers now, you will see that the information is inside of the request how wide the image is. And with this, I can just shave a few bytes on the wire, which is nice. Because the web is with us every day. And I'm now working for the web for 10 years. And unfortunately, we reached this state. I didn't build the whole thing, but I built parts of this. And I don't want to be that person because I think that the web should be respectful. And the most important thing that we should respect, in my opinion, is time. Because that's the only thing that we don't have enough of. What you can do is you can implement a link rel preload element in your HTML, or you can send a header, link rel preload. And what basically this tells the browser is like, hey browser, you don't know it yet, but you will request this in a second. So that it then will hopefully sit in the cache already and you can save bytes on the wire there. When we're talking about style sheets, critical fonts, maybe important JavaScript files, this saves seconds on a mobile connection. If you have certain CDNs in place, you have to be a little bit careful here though. You have to define no push, because link rel preload could be interpreted as an HTTP2 push, which is not the greatest solution still, because it doesn't take the browser cache into consideration. This will check the browser cache first, so this is the way to go. And this header is great to speed up critical resources, and I'm talking fonts and style sheets mainly, because these have a direct impact on user experience. So as the support of link rel preload today, we are pretty much there. But if the browser doesn't understand it, then it doesn't understand it. That's it. So you can ship it. And then we have an interesting one, which is, I call it the AMP reaction. 2 years ago or 3 years ago, I was giving this talk about the internals and how AMP works internally. So AMP stands for Accelerated Mobile Pages. It's this Google approach of fixing the web. It is a JavaScript framework, and it's maybe not. Let's stay with that. So it's a JavaScript framework. Technically, it's very interesting, though, but when they released this, what happened is that all the people that were working on web standards were just saying, this is not good. We cannot build our ecosystem on a pure JavaScript solution. And basically what AMP does, it limits what is allowed in a website. This is where AMP's strength is. It makes me very happy because now 2 or 3 years later, we have this header. This is the direct reaction to AMP. And I mean, how cool is that? So what you see there is a feature policy header, and you can really specifically nail down what is allowed in your website. When you're dealing with a lot of third-party scripts, maybe they shouldn't be allowed to vibrate the phone or ask for it. And you can basically define a lot of stuff there, going from the camera, microphone, MIDI, if that's your thing. Even though we made big progress here, we're still experimental here. But I like 2 of them very much, which are these 2, unoptimized media and unsized media. What you could do with this is you could build up a staging server or pre-prod server and enable this. And when your assets are wasting bandwidth because they are not optimized or resized, then it just doesn't work. And you or your QA will catch this issue. So if you want to deploy feature policy today, it's a little bit cumbersome, because you have to opt out of everything step by step. But it is like it is. This also works for iframes, which is cool. We're back at the third-party topic. And you've got a JavaScript API available to check, hey, am I really allowed in this website to ask for geolocation, for example? So I showed you the complete list just very shortly. But you may have noticed the most annoying thing of the web today was not in this list, which is, are we allowed to send you push notifications? Your new, It turned out that it's a little bit harder to disallow push notifications, so this discussion is currently on hold. So there's no way to disallow push notifications as of today. So how's the support for the feature policy header today? It looks like this. But again, you can deploy this, and if it works, and it only prevents one, can I access your location? Then it's already worth it for me. And speaking about respect, there's also this privacy part, right? Did you know that there's a do not track header? You can enable this in your browser of choice. The support looked like this, right? Which I think is pretty cool. I mean, ship what the user is asking for. And then what happened is that Safari dropped support because do not track was used to track people, which is ridiculous. Which then ended up with this. And now we kind of lost the battle. I think do not track was a nice try, but companies' websites, I mean, tracking is money, right? It doesn't matter if the user says, don't track me. Companies' websites will always track, no matter what the user says. And a lot of browser vendors discovered the same. So when we now looked, for example, this is Firefox, and more browsers will look like that very soon. What you see there is content blocking. So the do not track conversation is over, because browsers now offer stuff like this. And Firefox 70 was released yesterday, and look at this, 2,000 trackers blocked by default. Samsung is using some machine learning, because machine learning has to be in everything to prevent tracking. Safari went now with intelligent tracking prevention. I don't know if you noticed that, but the next browser war is there, and it's about privacy. So when we go to the responsible dev/respectful, you can see that the permission dialog is gone, because I set a feature policy header. And you see that the image that I pushed via a link URL preload was loaded second, even though it was completely somewhere else in the source order. So I think that today in 2019, it's actually very, very hard to build for the web. You have to consider design, content, performance, accessibility, frameworks, networks, devices. And this list is far away from being complete. So how do you ship good stuff today? Luckily, the developer tooling that we have also improved drastically over the last few years. So if you're a Google user, you can use Google Lighthouse, which you will find in the audits panel of the developer tools. And this is basically a monitoring or an auditing tool that gives you a lot of hints on how to build good stuff for the web. And it takes into consideration performance, accessibility, what are the others? Yeah, 5 things. Progressive web apps. And I think this is a great tool. It is not perfect, though. And I don't think that it is picky enough. So a tool that, for me, is heavily underrated is WebHint. WebHint is the kind of Microsoft counterpart to Lighthouse. And honestly, this is the most picky tool ever. When you run this for the first time, you get 250 warnings, and you feel like you're the worst developer. But I think this is great. I'm working for months to get a complete score on WebHint. Good luck with this. Talking about headers, if you want to get a more complete overview about stuff that I was not talking about, like referrer policies, more cookie stuff, this is excellent. Securityheaders.com. Just pump your site in there and see what headers you should use today. My friend Shep is maintaining this slide deck, HTTP headers for the hidden champions. Oh my God. There's so much knowledge in this slide deck, so if it wasn't enough facts what I presented, check this out. And Andrew Betts is working on specs for HTTP. He gives this talk that is called Headers for Hackers. Highly recommended. Pure knowledge in there. So to close the whole thing, I think that the web has to be safe, because none of you should mine cryptocurrency without knowing it. I think that the web should be affordable, because it's crucial for a lot of people, and it shouldn't matter where we are coming from in the world. And I think that the web should be respectful, because nobody likes permission dialogues and random annoying people on the street. So I think that the web has to be safe, affordable, and respectful, so that it is really for everybody. And I'm 5 minutes early. Thank you very much. I'm Stefan.